For this new video, we will see how to compare different thermal reaction norm of sex ratio. First, let's see what we have already seen in previous video. The conclusion of the first part, the first video of this series, was that to estimate the population equivalent of the thermal reaction norm for sex ratio, you should use the flexit double star model fitted using Bayesian model. This model must use only data obtained at constant incubation temperature, and it is important to remember that this pattern must not be used to estimate sex ratio from field. The sex ratio thermal reaction norm only works for constant incubation temperature. I will recall this regularly in this series because in literature we see often people applying this thermal reaction norm with field data, and this is completely wrong. In the second video, we have played with data from the marine turtle olive ridley, Lepidochelys.olivacea, and we have shown that with this data, if we use maximum likelihood, the result will be biased. We must use Bayesian statistics. This is not something that is a la mode. This is something more deep about what are statistics. Using this data, we have seen also that the pivotal temperature was determined with good precision, but the TRT was determined with relatively bad precision. Now we will continue to explore this model, and we will compare the thermal reaction norm for sex ratio of several groups of animals. We will stay in the Lepidochelys.olivacea species, but we will use different geographical information. So, remember, we used the Air Studio embryo growth package. We extract the Lepidochelys.olivacea information for constant incubation and sex ratio. And using this data, we saw that there was 3 different RMU that were represented in the data: West Atlantic, Northeast India, and East Pacific. RMU is defined as sort of geographical entities within a species. Okay, the pattern was fitted, and we saw this pattern. It was a typical pattern for turtles, with low temperature being masculinizing, higher temperature being feminizing, and it was fitted using Bayesian statistics. Perfect. Now we do the same with the data from 2 other RMU, East Pacific and Northeastern Indian Ocean. We obtain these 3 patterns of TSD, and now the question is what we can say. Is it similar, or the difference are due to something biological? It's not clear. Note that for Northeastern Indian Ocean, we have only 1 temperature with a mixed sex ratio, and then there is an infinity of curves that can explain this pattern. So in maximum likelihood we were stuck, but with Bayesian statistic we can say something. First, we can represent the distribution of possibility of, for example, here pivotal temperature on X and TRT on Y axis. And here it seems there is a clear distinction between Indian Ocean, RMU, and on the other side, Atlantic and Pacific. But is it true, or is it because there is a lack of data? Now let's do the same with SL versus SH. SL is the range of temperature where you have both sexes below pivotal temperature. SH is the range of temperature where you have both sexes above pivotal temperature. You see that for SH, we don't see really something, all are mixed. But for SL, it seems that we have a gradient. Northeastern India is lower, West Pacific intermediate, East Pacific higher. But we need to have some statistics, not just visual. And the statistics comes from WAIC, which is equivalent of IEC when you use Bayesian statistics. Here at the left, I fit the model of sex ratio thermal reaction norm for all the data grouped. So no RMU effect. At right, I fit the data with three different set of parameters. So I have here a RMU effect. And then using WAIC, I will be able to compare if the global model is sufficient or do I need specific model for each RMU. Let's do. It is not very easy. Okay, I let you check this in case you need, but we will just see the results at the end. The conclusion is that a global model is the best solution in 99% of the case. Only in 5 per 1,000 times a model with RMU effect is the best of these two models. So we can conclude with relatively good certainty that a single model is sufficient. So we have estimated the population equivalent of the thermal reaction norm for sex ratio using a flexit double star model for 3 different RMUs of the same species. When these results are plotted, it was not easy to decide if there was a difference or not for the TSD pattern or each parameter. The WAIC weight has been used to answer the question about if there is a difference. And we show that the probability that a single model is sufficient to model this thermal reaction norm was higher than 0.999. Then, with this data, it is improbable that there is a RMU effect. Always, I recall that you must not use this kind of data to estimate sex ratio from field. We will see this a little bit later. Bye.